Yakshamush! In this video, we're going to be discussing drawing three-dimensional figures. So, technical drawings are drawings that show different viewpoints of an object. Engineers and architects create technical drawings of products and buildings before actually constructing the actual objects. So, there are lots of programs in which you can use, even on PowerPoint, you can insert three-dimensional drawings and solids that can actually rotate and everything. So we're going to be looking at how to draw those in 2D. So, example 1, drawing a rectangular box. So step 1, we need to draw the rectangular bases, but in order for it to appear 3D, we want to draw them looking more like parallelograms instead of with the right angle. So we're going to draw them tilted. Alright, so I have the two bases there, the top base and the bottom base, and then I'm going to connect all of them using 4 vertical lines. And then in the last step, we are going to erase parts of the hidden edges. So if it were a complete solid, you wouldn't actually see those 3 edges. You would see all the rest of them. So in order to view it with some sort of depth, we go ahead and we create those dotted lines. Now, as you begin to draw them individually, I always draw my top base because you can always see it, and then I draw the bottom like that, and then I connect it, and then I draw the dotted lines in the back. Alright, that's how, after, lots of practice, that's how I draw it, so I don't have to erase anything. Alright, so isometric drawings. Technical drawings may include isometric drawings. These drawings look three-dimensional and can be created on a grid of dots using 3 axes that intersect to form 120-degree angles. So, this can be useful, especially as we enter Algebra 2. We are not only going to have an x and a y-axis, but we are also going to have a z-axis. And as we rotate three-dimensional figures, our kind of view of where the x, y, and z are all going to be different. So in order to create 3Ds and 3D objects and planes and everything, we need 3 axes. So if you ever hear about a construction project and any sort of 3D printer or something like that, they're more than likely going to talk about working on multiple axes. Alright, so example 2, create an isometric drawing. We're going to create an isometric drawing of the rectangular box in example 1. So, step 1, we want to draw 3 axes on a dotted piece of paper. So one important thing to notice is that this dotted piece of paper, the dots do not line up all right next to each other. So I'm going to have dots like this down one column, and then the dots in the next column are in between that, and then the dots in the next column find their windows as well, and so those ones line up, and then the next column would line up with the second row. Alright, so they have to be offset in order to properly draw this. Alright, so step 2, draw the box so that the edges of the box are parallel to the 3 axes. So here is an edge to the box, and it is parallel to this. The other edge that should be parallel is parallel to that axis. And then let me select a different color pen here. Let's go pink. Alright, those edges are parallel to this axis. And then last but certainly not least, let's go green. Alright, all of those axes are parallel, all of those edges are parallel to that axis. Alright, so then add depth to the drawing by using different shading for the front, top, and sides. So just like in a normal drawing of a house or a box or anything, you have a particular light source. We're going to go ahead and call the light source the sun here. Depending where the light hits, it's going to hit and shade the box differently. So typically, you don't have to do it this way. The box on the other side, the side of the box opposite of the light source is going to be a little bit darker, and then you have the shaded piece, and then I'm going to have the unshaded piece on top. Alright, so that's just one way of doing it, even if you don't have different color pencils or pens. Alright, so another view. Technical drawings may also include an orthographic projection. An orthographic projection is a two-dimensional drawing of the front, top, and side views of an object. The interior lines in these two-dimensional drawings represent edges of the object. So, here in example 3, create an orthographic projection of this solid. Alright, so we can see here that the front is, this front L shape, and then this side includes this piece and this piece. So you have to think about, what if it's not tilted and you're looking at it straight on, right? And then from the top, imagine if you were a helicopter and viewing it from the very top, from the sky. So we can see down here we have the front, top, and side projections. Alright, that's very important to make sure that we have the dimensions of all of the sides, so that we can then put them together to further construct them. And if this were a building, it's important to have this side all together, so that I can measure it for a certain billboard or windows, or order the correct amount of paint for that particular side. Alright, and over in this note on the left side here, it says think of the solids as being constructed of cubes. So just think about how you are looking at it from your view. How many cubes are you going to see? So this was one box, and then I would see another box and another box on the side. So it makes sense that they have 3 cubes here. And notice that there's kind of a break right there to show that there was a separation in depth, but there were 3 total blocks that you could see. Alright, so here are your practice problems for this extension. If you have any questions whatsoever, please feel free to email me or contact me during office hours. I look forward to hearing from you guys, and I really look forward to seeing your beautiful drawings.